Yep, so part 4 today, this will be the last section of that. So we're talking about domain of a function. This is something hopefully you guys have seen before. You've talked about it in Algebra 1, Algebra 2. We're just like a lot of stuff here. We're going to go a little bit more deep with that. So the first thing that I want to talk about is, and you don't have to write this down, okay? This is kind of just to help us get in the right frame of mind here. If you have a function like y equals 1/2 x plus 5. Okay. So this is just a normal linear function, right? Okay. You guys have seen this a lot, should be pretty familiar with it. The graph of that would look like that. A straight line with some slope that would continue in both directions forever, right? The domain, remember the domain goes with the input or the x values, okay? So the domain is from negative infinity to positive infinity, okay? That's kind of by default the domain of a function. It's all real numbers for which the function is real and defined, okay? And we'll talk about that in a second. There's nothing about a linear function that would ever make it undefined, right? It's just pretty standard plain Jane function. Now, you can specify the domain of a function. So for example, if I was using this function to represent anything like, say, cost of a business after so many months, okay, you might restrict it to 0 to 12. Or just something arbitrary, right? Because you wouldn't have an input that was negative if you're dealing with time. So I can restrict it to fit a certain situation, okay? But by default, if I don't specify the domain of a function, it's assumed to be all real numbers for which it's real and defined, okay? We'll write that down here in just a second. So if the domain of a function is unspecified, so if it's unspecified, the domain is implied to be all real numbers for which the function is real and for which it is defined. Okay? Now, what are some things that could happen in a function that would make it undefined?
Y squared.
Not quite.
If you divide by 0.
Yeah, undefined happens if you divide by 0, which for a function, it's when you have an x in the denominator. Okay? I'll talk about that more in just a second. And something that would make it not real is if you have the square root of something that is negative. Okay? So basically, these are kind of the two basic cases that can cause a problem with the domain or something that we're going to have to exclude. Okay? So to give you guys a little bit of an example, if my function is f of x equals 5 over x, okay, my domain, the x values, can be all real numbers except for what makes the denominator 0. So in this case, it would be all real numbers except for 0. Okay? Now, if it was like, it's not always going to be 0 just because you have a variable in the denominator. If it was x plus 1, I would have all real numbers except for negative 1, right? It's not going to be 0 plus 1 doesn't cause a problem anymore.
So
Okay.
if the answer equals 0, or the
Yes.
yeah, okay.
If the answer to this is 0, then that's going to be undefined. Same thing with our square root. The square root of a negative causes a problem. 0 is actually okay here. Square root of 0 is just 0. Okay? So my domain here would be all real numbers where x is greater than or equal to 0. okay? And by the same token, it's not always going to be around 0. If I had that, it would be all real numbers where x is greater than or equal to -5, because -5 plus 5 is 0. Anything less than that would make it negative.
Oh, I see what you mean.
Okay, so that's kind of the basic ideas that we're going to tap into. Okay, so example 1. Okay, so what we need to look at here, you kind of have to hone in on the important information, because it doesn't really matter what the numerator is. If we're looking to find the domain. I forgot to write the directions down, but you're wanting to state the domain of the function. Okay, the domain of the function here is going to be all real numbers for which it's defined. Okay, what would make it undefined? If that equals 0. Okay, if the answer to that is 0. So in order to figure out what x values are going to do that, we have to set this equal to 0 and solve. Okay. Now that is a quadratic, so you have to remember our methods for solving quadratics. You can factor, or you can use the quadratic formula. Those are the main ones, okay, that would apply here. Quadratic formula is kind of messy or long, so this one can be factored, so we're going to review factoring. Okay, this is a trinomial. Do you guys remember foiling?
Yes.
First, outer, inner, last.
Yeah.
This is basically like the result of foiling. Okay, so to factor it, you kind of have to think backwards. It's going to be 2 binomials, and the first thing in each has to be x in order to get the x squared, right? These last two numbers, the last is going to be 10. So 2 numbers both have to multiply to be 10, and the outer and the inner, so the sum of those has to be -7.
So 1 and 2.
Yeah, both have to be negative. Okay. These multiply to be +10, and the outer and the inner are going to add to be the -7x. Okay. Once you have that and you have it equals 0, in order for the product of two things to be 0, one or the other has to be 0, right? That's the only way you get 0 as an answer. So to solve this, when you're solving quadratics, you set each piece equal to 0. And then solve each individually. Okay. So this is kind of a refresher. You guys probably did this a lot in Algebra 2. So that's not our entire answer. Or it's the values that we're looking for, but we're thinking, I'm looking for the domain of the function. These are the values that are going to make this 0, okay? Those values are going to make my function undefined, so I cannot include those in the domain, okay? So basically my domain is all real numbers except for 2 and 5, okay? And you can check, if I plug 2 in for x, well, 2 squared is 4 minus 14, 4 minus 14 is -10, plus 10 is 0. If I plugged in 5, the same thing would happen. I would get 0. Okay. So if you're writing the domain, we've got 2 notations that you can use. You can use set builder notation or interval notation, which we've talked about already. I'm going to show you both here. You only have to use one or the other on your homework. Okay. So interval notation, set builder notation first, is going to be, our domain is the set of all x, such that x is not equal to 2, x is not equal to 5, and x belongs to the set of real numbers. Yeah, for the domain, because it's all real numbers for where it's defined. So basically, it's the set of all real numbers, and then we may have to exclude some values out of that.
So x will always belong, basically.
Yeah, for when we're doing the domain,
Okay.
yep, you're always going to have that part. The other way of writing the domain, and I'm going to say for most of this part, interval notation is probably going to be simpler. Interval notation, think about what this would look like on a number line. You don't have to write this down, but my domain is all real numbers except for 2 and 5. So I can't have those two values, but I have all of this, and all of this. So if you notice, I have 3 separate intervals, right? So my domain would be from -infinity to 2, and I cannot include 2. It cannot be equal to 2, because that's going to make it undefined. Union, then my second interval is 2 to 5. Still can't be equal to 5 either. Union 5 to infinity. The parenthesis means that it cannot be equal to 2. If it was a bracket, then that would mean it could be equal
It
to
could be
2.
equal to 2, okay.
Yep. So parenthesis is not equal to, like an open dot, bracket is like a closed dot.
And so then, how does 2 and 5 work there? Because isn't it saying that?
This is saying it's not equal to 2.
Yeah.
Not equal to 2.
Mm-hmm. How come you have to? I guess I'm confused why we need the 2, comma 5 there.
'Cause it's
Okay.
between two-
Because I have
Oh,
to
because one
include all of
that
this
works.
stuff.
Okay.
Yep. So I've got 3 intervals there, and the interval notation describes the endpoints of the interval.
Okay. That makes sense.
Okay, so for this one, I have a square root, and you kind of have to approach it the same way. My domain is going to be all real numbers, where this is going to be real and defined. So, what would give me a non-real answer?
If it's negative.
If the answer to that is negative, right? Okay, so we're gonna have to take the same thing, or do the same sort of thing. Take that, and if it needs to be not negative, it has to be 0 or greater, right? The answer to that can be 0, because the square root of 0 is just 0. 0 is okay under a square root.
Yeah.
So I need to take this and set it greater than or equal to 0, and then just solve it. Okay, so add 1, divide by 4.
Yes, teachers, we are going.
Okay, so this is basically the domain. My domain is all real numbers, but it has to be greater than or equal to 1/4. Because look, if I plug 1/4 in, I get 0, right? That's allowed. Anything greater than that is going to be greater than 0. That's fine. If I put anything less than that, if I put 0 in, I get -1. So that causes a problem. So my domain, and on this one, especially if you just have one interval and it's a solid range of real numbers, interval notation is going to be your best bet on that. So it's everything from 1/4 to infinity, so you don't have to draw the number line, but that would be a bracket with 1/4 to infinity and parentheses. Yeah, that's how it would look in set builder notation. But if you've just got one interval, usually I'm going to say for most of the problems here, interval notation is going to be easier. The one where, like the first one that we had, where I had 3 separate intervals, on that one you could kind of make the argument that it's easier to just say, well, x is not equal to 2, x is not equal to 5, x belongs to real numbers. But it's kind of a toss-up on that one, which is easier. So
It's overly complicated.
it's really not that bad. Basically, this one is just a kind of a combination of the last two. So if I look at the stuff here, so numerator doesn't really matter. The stuff that I circled there cannot be negative, right? Because it's under the square root. But unlike the last one, it can't be 0 either. Because if the answer to that is 0, then I get a 0 on the denominator and it's undefined. So it can't be negative, it can't be 0, so 2x minus 3 has to be greater than 0. Okay. And then we just solve that. So 2x is greater than 3. And x is greater than 3 over 2. So for our domain, again on this one, interval notation. You could use set builder notation. Interval notation is probably going to be your best bet. So my range is from 3 over 2 to infinity, but I can't include 3 over 2. Okay, so it has to be a parenthesis on both. Okay. So h of a equals square root, oh, this is supposed to be a squared minus 4. Sorry about that. Okay, so on this one, it's going to start out the same as all of our others. If I look at what's under the square root, okay, I know the answer to that cannot be negative, right? Okay. So I come over here, a squared minus 4 has to be greater than or equal to 0. Now this is a quadratic, but since there's only the squared term, I don't have to factor, I don't have to use quadratic formula. I can isolate the variable just by adding 4, right? So if I add 4, a squared is greater than or equal to 4, and then I can just square root to solve, okay? Be careful though here, especially with inequalities. When I square root, I get a positive and negative answer, right?
Yeah.
Okay. With inequalities, that's a little weird. If I square root, I get a is greater than or equal to 2, but then the other one is going to be a is less than or equal to negative 2. You have to flip the sign from the negative one. And that may seem a little weird, but if we go back up to this line, it makes sense. Think about the numbers that would make this true. For a squared to be greater than or equal to 4. Well, things greater than 2, obviously, like 3 or 4, if I plug in, will be greater. But if I plug in negative numbers, I need the magnitude of it to be greater than 2, like negative 3 squared or negative 5 squared.
Oh, and you can do that because it's,
Yep. Okay. So on a number line, that would look like things over here. And the things over here. It's just not the stuff where the absolute value is less than 2. Okay. So yeah, your domain, I would probably use interval notation, negative infinity, and then parenthesis or bracket.
Bracket.
Bracket. And then I have a second one, so union to infinity. And I believe that is the last one. Yep.